Okay, welcome to section 4.6. Here we're going to start to use the calculator a little bit more in justifying our answers that we did by hand. And eventually the better you get with your calculator, the less work you can do when you are in a hurry, if you will, when you're in Calc 2 and Calc 3 working with derivatives. So the first thing let's look at is finding the actual derivative of this by hand. The calculator will make a graph of the derivative, but I like to find the original equation for the derivative because that's more precise in the calculator. So y prime is going to be 3 times, bring down to 2/3, multiply to our x, subtract 1 from our power, negative 1/3 minus 2, and we can clean that up. We can have it as cancel the 3's, 2x to the negative 1/3 power minus 2, or 2 over the cube root of x minus 2. Either one of these are fine to plug into your calculator. So y1 gets the original function all the time. y2, I like to put in my derivative equation that I have found. In y3, we'll talk about how to enter this into the calculator where it finds the graph of the derivative based off of the original function. Now there's always a little question there in what happens. There's rounding errors when it goes through this. All right. Next, you'll see that I said put a change on your interval. A lot of times you will see by problems they will give you the size of the window that they want. So here's a full-blown explanation. The first set of brackets, this represents your x's. That's your x min, x max, x scale. Second set of brackets is your y's, y min, y max, y scale. And I'll show you how to enter these in the calculator. So here's my two graphs. The blue is y1, that's my original function. The red is my f prime. All right, now entering y3, so when we enter this, you're taking the derivative with respect to x of this equation in y1, and we want to evaluate it at all the possible x's. You could evaluate it at just one particular value, and if you were to do this on the home screen. So you could punch this into the home screen and say, oh, what's the derivative value, say at x equals 1.5. Enter this in, put in 1.5 here, and it'll find that specific value on the curve right there. Okay, so here's the graph of y3. Now notice that it's tracing right over the red graph, and again, that will be shown in my video, which is coming up. Hit the y equals button. So we're in our window here. So we're going to type in our 3x raised to the alpha y equals fractional power. Put in our 2 over 3. Make sure you right arrow out of there. Minus 2x. Alright, then for the derivative that we found that we're going to enter, was 2x raised to the negative. Make sure you hit the negative button, not the minus. Alpha y equals fraction 1/3. Right arrow out of there, minus 2. And then we're going to go into y3. This is where you get the calculator to build your derivative graph for you. It's under math, down here, number 8. So you can down arrow to it or just press 8. And we're going to put in x in the first box. Here we want to do just y1. So alpha, trace, enter, right arrow, and then here put in x. Now, if you have an older calculator that doesn't have that alpha shortcut, you will have to hit bars, right arrow to y bars, enter on function, and that's where you'd hit enter for your y1. So that's what you would have to do up here. I'm just going to delete that out right there.
Okay, then our change of our window, x min -2, x max 2, and we wanted this to count by 0.25. And -10, 10, and 1 was our y's. We'll leave that the same, and we make our graph. Now here, when you hit enter, you can pause it, and you'll see this little spinning circle up here. So the reason I paused it, so you can see there's the graph in black tracing over our first derivative function that we entered. So that's one way you can check to see if your derivative is correct, is by through graphing this here. Okay? And then we'll come back and I'll show you how to do the zeros in the next one.
Okay, now finding our zeros for our derivative. So I'm going to work with the 2 over the cube root of x minus 2, and we need to solve this for x. So first things first, I see x in the denominator of my derivative function, so that indicates that my graph has a vertical asymptote, which we saw previously, and 0 is a critical number. So again, just to overemphasize, there's the derivative function in both black, even red. Remember, the black graph went over the red graph. And if I hit x equals 0, you can see there's no value there for y. Now again, if you do on the black graph, that's the one generated by the graphing calculator, there'll be rounding errors in here, and we know there's no point at 0, -2. So we continue on, we'll solve this for x to find our other critical number. Add over the 2, multiply over the cube root of x, divide by 2. We get a 1, we cube both sides, x is equal to 1, that's my other critical number. So we need to find, on the derivative graph, 0.25, 0.5, 0.75, 1, yep, there's an x-intercept right there. So on your calculator, you can use the 0 command, and that will be shown in another video here in a second. So there's my 0 for my derivative, which means right up here is a local extreme, and it appears to us that we have a local max. You can also do this command with the y sub 3 equation generated by the calculator. Just keep in mind there will be rounding errors. All right, so part 4, evaluate each critical number and endpoint. So we start with our function. This is how we used to do it by hand. You plug in the -2. Okay, -2 squared, that's the x squared, is 4. Then we're going to take the cube root of 4. -2 times the -2 is a +4. We would go to our calculator, enter this, and get our decimal value. F of 0 is a critical number. 0 in for both x's. Are going to 0 them both out. That's a 0. F of 1, well, the cube root of 1 squared is 1, so 3 times 1 is 3. 2 times 1 is 2, so -2 is a 1. F of 2, we'll get the exact same first term, whether I put in a -2 and squared or a +2, but now it's -2 times a +2, so it's -4. Went to my calculator, copied down this statement, and changed a plus to a minus to get this decimal. In your calculator, all you have to do is hit the trace button and make sure that you're in y1, the original function, and you can type in -2 and it gives you the y value. Type in the 0, it gives you the 0 value. Type in the 1, gives you the 1. So there's my local max at 1, 1. Type in the 2, and there's that 0.7622. All right, now, if you know how to do this, then skip forward in the video as I demonstrate how to do this with the calculator.
Show you how to find those values on your calculator. It's really important to watch your equations that you have up here on the top. So we know our derivatives were in red and black. Blue is the original curve. So if we want to find where our derivatives are undefined, I'm going to hit trace, and this is where you see the equations on the top. You hit the down arrow, you go through your graphs. So as you can see on this corner right here, I'm going to trace to the left. That's a corner right there. So we don't have a derivative value. So if I put my cursor right at 0, you can see when I hit the down arrow, there's no y value. Now, this is kind of crazy. That's why you got to watch these graphs. This is the one in black. This is the calculator making the derivative graph for you. But since you see that it's a vertical asymptote here, you know nothing exists here. I have no idea why the calculator does that. All right, so that verifies that 0 was a critical number. And our other critical number was, we had, what was it, a value of 1, I believe. So this is where we follow our derivative curve and look for the x-intercept right here. So we can hit second, trace, ask for 0, number 2. Now, don't be in blue. It defaults to y1 all the time. So if you don't want y1 on, you can go to your y equals and turn it off, and I'll show you how to do that in just a second. Hit the down arrow. Here we are in red. So I'm going to cursor over. You can click over, or you can just type in a number. All right, so I'll just click over to, that looks about good. I still have positive y's. I hit enter. Now I have to go past the 1. Now you notice I have negative y's. I hit enter. And my x-intercept is somewhere in between there. Just hit enter again. And there's my 0. And I can do the same command on my derivative function that the calculator did for me. So left bound, again, I need to have positive y's, enter. Right bound, I have to have negative y's, so it crosses the x-axis, hit enter. And again, this is kind of crazy. It has a rounded value here for this x-intercept. So when you see this happen, it's going to be a 0. And sometimes it might be in reverse where you'll see something like this. If I hit the traces on, I type in a 1. Notice I get this for a value. This is a 0. That e to the negative 7 means there is 6 zeros. I have to move the decimal point 7 places to the left. It's a rounding error. I don't know why the calculator does that. We just have to cope with it. Okay, now finding our values off of the blue curve for our endpoints, which we did with -2, the 0, our 1, and the 2. So we're in the trace mode, up arrow to get to the blue curve. All you got to do is type in -2 in the trace mode. There's your y value that we had found earlier. Type in the 0. There's my 0 value. Type in the 1. There's our value we got for f of 1. And we type in our 2. And there's that decimal point 7622 that we've gotten earlier. So you can do all this from the trace mode. Sound good? Now, to turn off the blue graph when you're doing just the derivative, if you go back to y, and you come in here and you put your cursor on the equal sign to enter, it's not highlighted, you graph it, and you see the picture done over again, and now you're just working when you hit the trace. Now it starts with y sub 2, the very first equation you plugged in. All right. So now you can do these on your own for all problems to double check.
All right, try this problem, setting it up in your calculator, doing the derivative, and I'll check back with you in part 2 with all the answers.